in the preceding section, we can introduce some indefinite integral formulas. For example, we gave some of them actually in the previous record. For example, since derivative of the sine x is cosine x, we can say that from here, integral of the cosine x, indefinite integral of the cosine x is sine x plus c, because sine x is the one of the antiderivative of cosine x. But in general, we know the chain rule from the differentiation. For example, sine x squared derivative is cosine x squared times 2x. So from here, you can conclude 2x times cosine x squared dx integral equals sine x squared plus c. So in this section, we discussed that idea. In general, you can consider as a reversing the chain rule. Okay. What we know about the chain rule? Derivative of the f of g of x is derivative of the f of g of x times derivative of the g of x. So, integral of the right hand side equals inside of the left side. I mean, from here, the integral of the f prime of g of x times g prime of x dx equals f of g of x plus c, constant term c. So, now we consider indefinite integral formulas and procedure based on the chain rule for differentiation. So here, if we recognize an integrand as a chain rule, form f prime of g of x times g prime of x, we can easily find an antiderivative, and it is indefinite integral in the right hand side form. Okay, so from here we gave the following formula: integral e external function, the derivative of external function of interior function times interior derivative of interior function equals external function of interior function plus c. So, in the application, we should find the interior function, okay? So, if you can decide the interior function, for example, here, this is interior function, you should find the derivative of the interior function or differentiation of the interior function. So here we say interior function is u. So differential of the u is derivative of the interior function times dx. So then from here easily you will obtain the following formula: e prime of u du, and by the antiderivative idea, it is easily can be concluded, which equals e of u plus c, and u is interior function. So as a result, we reach the above result. Let's give a small example. We are interested in finding the indefinite integral of the following function. For example, let's write 3x squared e to power x squared x cubed minus 1 dx. So the integrand appears to be the chain rule. Form e to power g of x times g prime of the x4. Okay, so here we should find the g, or we should find the interior function. Here, this term is the interior function. X cubed minus 1 is the interior function, okay? So here, let x cubed minus 1 be u. So this implies differential of the x cube is 3x squared. Derivative of minus 1 is 0. So dx equals du. So in this formula, if we say this is u, this component with the dx, okay, 3x squared times dx give us du. So this integral I equals e to power u times du. And we know the integral of the e to power u, which is e to power, our variable is u plus c, and u is x cubed minus 1. So this is e to power x cubed minus 1 plus c. So this idea, this procedure is called substitution for the indefinite integral. This rule is very important actually. So we can write some formulas. First of all, derivative of 2 f of x to power n times f prime of x dx equals, if you say here f of x is u interior function, this will be du, okay? So this equals u to power n plus 1 over n plus 1. U is f of x, so f of x to power n plus 1 over n plus 1 plus c. Of course, here n should be different than 1. And second formula, e to power f of x times derivative of the f of f prime of x dx, which is very similar to the above example. So this equals e to power f of x plus c. If you say f of x is u, f prime times dx will be du. Directly you can conclude. And the last formula, 1 over f of x, here n should be different than minus 1, not 1, I'm sorry. This is the n equals minus 1 case, f prime of x dx. So now if you say f of x is u, f prime dx will be du. If you say this is u, f of x, this is du. So you will obtain 1 over u du. This is ln u. So ln u is f of x. So this is ln absolute value of u. Ln absolute value of the f of x plus c is the integral of that one. Okay, so substitution technique is a very important technique to calculate the some kind of the indefinite integral. Of course, it is not sufficient for us. We will need some other techniques you will learn in the future records. As a conclusion, let's give a procedure to apply the integration by substitution techniques. Okay, the procedure. First step, select a substitution that appears to simplify the integrand. Okay, your aim is to simplify the integrand. In particularly, try to select u so that du is a factor in the integrand. Okay, so here your aim is select u so that differential of du is a factor in the integrand. The step 2, sorry. Express the integrand entirely in terms of your new variable u and du. Entirely. So I mean, at the same time, you cannot include the u and the x variable, okay? Express the integrand entirely in terms of u and du, completely eliminating the original variable, which is x, and its differential, which is d of x. In step 3, evaluate the new integral if possible. Actually, our aim is to simplify. So after simplification, you should be able to evaluate the integral. So evaluate the new integral if possible. As a last step, which is step 4, express the antiderivative found in step 3 in terms of the original variable. So you should turn back your original variable. Okay, so express the antiderivative found in step 3, express the result, let's say, your result in terms of the original variable. Okay, let's show a very simple example. For example, 3x plus 4 to power 6 plus 3 dx. So to calculate this integral, you should say 3x plus 4 is u. What is the derivative of the 3x plus 4? 3. So 3 dx will be du. So as you see, this is a factor of the integrand. 3 is the factor of the integrand. So this integral can be written as the following form: u to power 6 times du. And easily you can calculate this integral: u to power 7 plus 7. Okay. So let's explain this step. This is step 1. Express the integral entirely in terms of u and du. This is step 2. And evaluate the new integral if possible. Here it is possible. So this is step 3. And last step, turn back the original variable. Express the result in terms of the original variable. So this is step 4. And the result is u is 3x plus 4. So 3x plus 4 to power 7 over 7 plus constant term c. In the lecture, I will show some other kind of the question by using substitution. Actually, in some case, the integrand must be modified before making a substitution and using one of the integration formulas. Okay, so by that way, I will give them some question in the lecture. And sometimes we should have some modification, not modification, maybe some trick to calculate the integral. Directly you cannot apply the substitution, or it is a bit difficult to explain. So let's consider the following example. I like this example. X squared x plus 2 dx. Here, if you say x plus 2 is u, that's okay. This is a good idea. But dx is du. But in the numerator, you will have a x. Okay. But from here, you cannot calculate this integral. So how we can calculate? This is a good idea. Let x plus 2 is bu, and this implies dx equals du. So what is our integral here? X, we have a x. This is square root of du, dx is du. But it is not logical to write the x over square root of du because of the step 2. In the step 2, it is said as express the integral entirely in terms of du and du. But here we have x. So this is not a good idea. So we should write instead of the x in terms of du. This is the tricky. So from here, x is u minus 2. So instead of the x, you should write u minus 2. Now you can evaluate this integral. Maybe it seems a bit difficult for you, but it's not difficult. U over square root of the u minus 2 over square root of the u du integral. Easily this integral can be evaluated. 1 u to power 1 over 2 square root of the u minus 2 times u to power minus 1 over 2 du. Okay, here you can say that u to power 1 over 2. So as a result, u to power 3 over 2 over 3 over 2, this is step 3, minus 2 times u to power n plus 1, 1 over 2 over 1 over 2, plus constant term c. And according to step 4, let's turn back to our original variable. U is x plus 1, so 2 over 3, x plus 2 to power 3 over 2, minus 4, x plus 2 to power 1 over 2 plus c is the answer. In this lecture, I will solve some different kind of the questions. Also, we have some application for the integral. You will see in the lecture time, and also you can find these applications in your textbook.